Project manager on FSO Quard. Maybe a trickle of telemetry left, but you just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project manager off the net.
The Cassini-Huygens spacecraft spent more than 10 years studying the crown jewel of our solar system, with its massive size, beautifully adorned rings, and countless moons offering more data than we could have ever imagined. Cassini's fate has been eternally sealed inside the ringed gas giant, yet we continue to learn more about the second largest planet of our solar system. Today, we'll discuss what we know about Saturn and explore some of the discoveries uncovered by the Cassini spacecraft. Saturn formed about 4.5 billion years ago when gravity pulled in leftover gas and dust from the birth of our Sun. Orbiting 1.4 billion kilometers from the Sun, Saturn is the most distant planet visible to the unaided eye, and in fact was the last planet known since antiquity. The remaining planets of the outer solar system have discoverers, with Neptune being the first planet discovered solely by mathematics. The oldest written records of Saturn date back to the Assyrians in 700 BCE. These Babylonian astronomers named it Star of Ninib. Around 400 BCE, Greek astronomers also observed Saturn, but they didn't yet realize it was a planet. Believing it was a star that wandered across the night sky, the ancient Greeks named it Kronos, the personification of time, leader of the mighty Titans, and Zeus's own father. The ancient Romans later adopted the name of Saturnus, which was Cronus's Roman counterpart. More than 2,000 years passed before the invention of the telescope allowed Galileo Galilei to observe Saturn's rings, but he mistook them for a triple planet. In 1655, Cassini-Huygens correctly discovered Saturn's rings and its largest moon, Titan. Today, we know that Titan is the second largest moon in the solar system, second only to Jupiter's Ganymede. In all, Saturn has 53 confirmed moons, each unique and fascinating worlds in their own right. A Saturnian year is agonizingly long, taking 29 Earth years to complete one revolution around the Sun. One day on Saturn is only about 10.5 hours, however, it remains difficult for us to determine a precise time due to the lack of a solid surface. This incredibly fast rotation causes Saturn to have a shape of an oblate spheroid. Centrifugal forces literally stretch the planet at the equator, resulting in a radius 10% wider than its polar radius. Interestingly, the planet closest to a perfect sphere in our solar system is Venus, due to its incredibly slow rotation where one day is equal to almost 117 days on Earth. With an average radius about 9 times that of Earth, Saturn is truly a massive planet that must be an incredible sight to see in person. If you include Saturn's rings that extend up to 282,000 kilometers, then it would cover about 2/3 the distance between the Earth and the Moon. At 568 septillion kilograms, Saturn's mass is just over 95 Earths, and its volume is even more impressive at about 763 Earths. Although Saturn is incredibly massive, its mean density is only 0.687 grams per centimeter cubed, which is about 30% less than water, and 8 times less dense than the Earth at 5.52 grams per centimeter cubed. Most of Saturn's volume is composed of hydrogen and helium, with the remaining volume consisting of methane, ammonia, hydrogen deuteride, and ethane. It's believed that Saturn has a solid core composed of iron, nickel, and rock. Surrounding the core is a thick layer of liquid metallic hydrogen. This is followed by a layer of liquid helium saturated molecular hydrogen that gradually transitions to a gas as pressure decreases with increasing distance away from the core. Electrical current within the metallic hydrogen layer is thought to give rise to Saturn's planetary magnetic field. Although weaker than Earth's magnetic field, Saturn's massive size gives it a magnetic moment 580 times that of Earth. Saturn's interior is 2 times hotter than the surface of the Sun, reaching 11,700 degrees Celsius at its core, and it radiates 2.5 times more energy into space than it receives from the Sun. Infrared images show the incredible amount of energy as it glows a brilliant red deep inside of Saturn. This energy drives the weather on Saturn before it eventually escapes into space. Similar to Jupiter, one mechanism of that heat generation may be through the raining out of helium droplets deep within Saturn's interior. As the droplets descend through the lower density hydrogen, the process releases heat by friction and leaves Saturn's outer layers depleted of helium. These descending droplets may have accumulated into a helium shell surrounding the core. Saturn is blanketed with a hazy, light brown appearance due to a mixture of yellow ammonia crystals in the upper atmosphere, while the lower level clouds appear to consist of either ammonium hydrosulfide or water. Ultraviolet radiation from the Sun causes methane photolysis in the upper atmosphere, leading to a series of hydrocarbon chemical reactions, with the resulting products being carried down by eddies and diffusion. Like Earth, Saturn is tilted on its axis by 26.73 degrees, whereas Earth is tilted at 23.5 degrees. This means that Saturn experiences seasons. Although mostly calm in appearance with a faint banding of clouds visible in the upper atmosphere, the weather on Saturn is hellish. Wind speeds can reach 1,800 kilometers per hour, second only to Neptune. Some of the most destructive weather in the solar system is found at Saturn's poles. A gigantic storm rages at Saturn's south pole. At 5,000 miles across, it could nearly swallow the entire Earth, and the clouds are 5 times higher than the eye wall of hurricanes on Earth. Saturn's north pole is a 6-sided jet stream, spanning about 30,000 kilometers across. The hexagon is a wavy jet stream with a massive, rotating storm at the center packing 500 km per hour winds. The sides of the hexagon are each about 13,800 kilometers long, which is longer than the diameter of the Earth. Studies have shown that hexagon shapes can form in an area of turbulent flow when liquid was rotated in a circular tank at different speeds at its center and periphery. Roughly every 30 years, a global weather event of grand scale occurs. We were lucky enough to witness one during Cassini's visit to the ring planet. Known as the Great White Spot, scientists found that water vapor and other materials rise up from 160 kilometers below the cloud tops. The vapor freezes, causing the white appearance we see during the storm. The last storm wrapped around the entire planet, spanning some 300,000 kilometers. Saturn's rings are undoubtedly the feature that makes it so stunning among all the planets in the solar system. Although we see them as a disk of light, they're primarily composed of chunks of ice and rock. The reflective nature of ice is the reason they're so stunningly visible to us on Earth. Most of the chunks are tiny, but some are the size of a house and a few are as large as mountains. The nature of Saturn's rings were not understood until 1859 when James Clerk Maxwell submitted his overwhelmingly convincing predictions. Maxwell proved that a regular solid ring could not be stable, while a fluid ring would be forced by wave action to break up into blobs. Since neither was observed, Maxwell concluded that the rings must be composed of numerous small particles he called brickbats, each independently orbiting Saturn. It would be over 100 years later before his predictions were confirmed during the Voyager flybys. Saturn's ring system extends up to 282,000 kilometers from the planet, yet the average vertical height is no taller than a 2-story building, or typically about 10 meters. The rings are named alphabetically in the order of discovery and can be a bit confusing. Beginning closest to the planet, the main rings are C, B, and A. The Cassini division is a gap spanning 4,700 kilometers between the B and A rings. It was named after Giovanni Cassini, who first discovered the gap. In addition, a number of fainter rings have been discovered more recently. The D ring is exceedingly faint and closest to the planet. The F ring is a narrow feature just outside the A ring. Beyond that are 2 far fainter rings named G and E. Weird and interesting things occur inside the ring structure. There are braided rings, ringlets, and spokes, dark features in the rings that form and initially circle the planet at different rates from that of the surrounding ring material. Pan and Daphnis are tiny shepherd moons that orbit between the gaps in the rings. At 30 kilometers wide, Pan is the second most inner moon orbiting in the NK gap. Stray particles are collected by Pan as it works to keep the gap open. This has caused a rather interesting disk shape at its equator as the ring material is deposited on the moon. Daphnis is much smaller at 8 kilometers wide, orbiting within the narrow Kela gap. Waves can be seen as it interacts with the nearby ring material. The moons Janus and Epimetheus proved to be a truly fascinating discovery. Saturn's inner B ring forms a 2-to-1 orbital resonance with Janus, as the ring orbits twice for every 1 orbit of Janus. This image is deceptive as it appears to be tilted away. However, as a wave propagates away from the resonance, the wavelength decreases, creating this illusion. Every 4 years, Janus and Epimetheus switch places in their orbits, which creates new crests in the waves. This has provided a glimpse into the past as the waves form a visual orbital history of Janus and Epimetheus. Density wave theory was successfully applied to this incredible discovery, which explains the creation of spiral arms within a spiral galaxy like our own Milky Way. In effect, Cassini witnessed this creation on a much smaller scale. Perhaps the most exciting discoveries of Saturn are the moons Titan and Enceladus. We'll talk more about the moons in another episode, but many now believe that these 2 moons are the best candidates for finding life beyond Earth. With Enceladus ejecting geysers of water from a subsurface ocean, samples are offered for the taking to any spacecraft passing by with the capability of analyzing collected samples. I hope we'll be able to visit this incredible system again in the future, for many unanswered questions remain. Until next time, my friends, I'm Tex. Happy orbiting.